So basically what we're doing right now is we're scanning the entire vehicle. So we're gonna scan the entire external of the vehicle, the bottom, which is basically flat bottomed. Ryan's done a really nice job building this car overall. I think it's one of the nicest cars I've honestly seen in person. That being said, we're basically gonna scan the whole car. We're actually scanning the underhood right now. So we're gonna do a dummy engine block. We're gonna get some through ducts for the radiator. We're gonna actually model and analyze as if the coolers are there, which they are in real life. We're going to model the hood louver and then basically the lack of a fender liner. We're modeling all of that type of stuff. Through ducts, these vents are actually functional. Same with the ones on the side. We're modeling all of that to try and get it as accurate as possible so that when we run our analysis, it's gonna be applicable to what they see in real life.
Yeah, so we scanned the car, turned the car into like a solidified CAD model, and ran CFD on the baseline package as it came back from World Time Attack. And so we gave that to him as sort of like this is where you're starting from, and we kind of used that to figure out where we wanted to go. The goal shifted very quickly to sort of like, this is Ryan's dream car, and it's a time attack car, and if he's gonna go through this once, he might as well just kind of go big the first time and make it everything that he could ever want it to be. And so we came up with the goal of 2,000 pounds of downforce at 120 miles an hour, but also a percentage of front balance and a kind of adjustment range that he could be within. So he'll be able to tune the balance of the car with the rear wing, and if he ends up at a much lower angle of attack, he'll dip below 2,000 pounds at 120. But if he ends up wanting a more rear biased car, he'll probably end up above 2,000 pounds at 120, but that's kind of the range that he's in. Yeah, so we scanned most of the engine bay for this one too, but yeah, in this area, everything's open to the engine bay. You can see some of the carbon intake tube comes down through here. This is the sort of the OE chassis leg. There's some oil cooler exit ducting. Yeah, so we had to model all of the oil cooler ducting, get rid of the wheels, and some of the suspension and stuff. Yeah, so it's a little bit simplified, but a bunch of the engine bay geometry's in there. The oil cooler ducting, radiator ducting, the oil coolers are in there. Here's one of those vents that was open. Like this area was all open as well. There's some openings here. Kind of through to the rear wheel well. We looked at the diffuser too. The diffuser's a cool piece, and it would be expensive to replace. We kind of looked at potentially adding some strakes to it to improve performance. Just for the amount of work, nothing really seemed all that. For the amount of work, nothing really seemed all that worth implementing, and this diffuser's cool. It looks the part. We retained as much of the original chassis mounting that he had for the wing, and we've just kind of recommended some areas that he beef up the mounting structure a little bit, but it should be more or less bolt on to what he already had. Got his logo on there. This is kind of a cool part. The final number, like, not that it's particularly relevant. Like it's so easy to make little tweaks and numbers will change, but our final number at 120 was like 1998 pounds, and the balance was right in the kind of the middle of the range that we discussed. So it's definitely going to be, yeah, I mean his original Aero package was probably more, it was a lot more conservative. So he's definitely going to have a big jump in downforce. It's going to be interesting keeping in touch with him as he does some testing on the car. I imagine it's going to really impact his suspension setup and spring rates, and it'll be exciting to see some results, see some footage of it on the car.
Cool.
I think he's in for a surprise. It's going to be probably a pretty different car than the last time he drove it.
All right, so we are on the final stretch of the Ryan Tuerck project. We made over 3,000 pounds of downforce at 160, which was his latest goal. He initially started out a little bit lower, then he raised the bar a little bit. So it took us a little bit more time to finalize the design concept and get it to the point where we're ready to make it. And then making it actually proved to be a little bit time intensive as well, but we're now finally getting there. We have the dual element finish. We have the front splitter end plates getting bonded on with 3D printed vents. So this is a front splitter end plate. This is gonna be a grind strake as well. And then we have the front splitter and we're gonna bolt it all together, make sure everything goes together, and he is picking it up next week. So trying to get this done for him this year so that he can install it on his Formula Supra here shortly. All right, so we are joined back with Ryan Tuerck's front splitter. It's a pretty cool unit. I need to actually weigh it because it's crazy light for what it is. It's the size of like half a car, and it's pretty cool. So I've mapped out the center point of the splitter. We're now installing the titanium grind strakes, which we keep in stock. These are available. This splitter gets 4 of them. That's to keep the carbon hopefully alive for a little bit longer than otherwise it would otherwise happen, I guess. So we've got them marked out based off of our handy dandy drawing. And we're gonna hopefully drill into some phenolic and not just empty carbon. So yeah, so we're drilling into a very expensive front splitter today. And then we're gonna install the end plates, make sure all that stuff bolts up. We'll flip it over, show you the bottom side because that's cool as well. And then we're gonna finish installing everything on the rear wing. Show you guys that stuff too. That's up there. Yeah, cool. All right, so we are finally finished with the final products that we developed for Ryan Tuerck and his Formula Supra build. This is our V2X dual element, which has gone on a lot of race winning vehicles at this point, specifically up Pikes Peak, but also in some various other racing sanctioning bodies. The V2X is a 300 millimeter single or main plane with a 200 millimeter secondary element. We have our typical 500 millimeter squared end plate, and then we ended up cutting out some holes for it so we could put some 3D printed vents, and this improves efficiency of the rear wing. The mounting is very specific to Ryan Tuerck's Supra, so we scan the inside of his trunk, we scan the outside of his trunk. The beauty plates will mount to the trunk on the carbon fiber trunk that he has, and then it's got a 3D printed sandwich plate on the bottom side which will bolt through and it'll look really nice. We have the cross brace, which he had previously as well. We wanted to retain that, but we wanted to make it our own, so we designed our own. Uprights have some nice 411 logos on it, and then Verus engineering as well. So at the end of the day, this is the large producing rear downforce providing unit. This produces a lot of rear downforce. All right, so we have the front splitter in front of us. Today, we ended up drilling, 8 holes in the carbon fiber. The carbon fiber has phenolic installed in it in these 4 locations. It also has aluminum pucks installed throughout in specific locations, which we're gonna let Ryan do the final install. We have CAD of this, so he has locations of those aluminum pucks, and we designed that specifically based off of locations that he provided to us, and then that'll be where he mounts it to the chassis and potentially splitter ties. So we have a few splitter tie locations. We don't know if it's gonna be strong enough without the splitter ties, so I didn't wanna start drilling holes until we know that for a fact. But otherwise, I mean, this thing is super stout. The strakes for the diffusers are actually removable so that if they get ground down, we can replace them. Titanium skid vanes are for abrasion resistance so that we hopefully don't destroy this carbon splitter over time. The end plates are polyweave with 3D printed carbon nylon vents. The polyweave should abrade really nicely and take a beating, while the carbon splitter hopefully stays nice over time again. So we attempted to think of everything that could come up and implement it into the design and the building of this. This front splitter is one of the higher downforce producing splitters that we've ever developed. And I hope at the end of the day that Ryan really appreciates it and likes it, because it was a lot of effort on our front and definitely a lot of time as well. We were kind of curious on what the weight was at the end of the day, and this is for our own information, and Ryan can use it as well. The only thing that hasn't happened to this front splitter is the mounting that he intends to put on it. So if he does splitter ties, that's going to add some weight, and if he does, when he does his quick releases, I can even see where it's at. It's like right there, right there. There's some aluminum pucks in here that he's going to drill through and then mount that to, and then that'll add some weight to it. But overall, what I'm trying to say is titanium skid vanes are on, the polyweave end plates, which are decently, there's some decent weight there with 3D printed end plates. Those are on, and it's basically ready to be used otherwise. So let's see what it weighs. All right, yeah, I would say 32 pounds.
That's pretty light.
Well, for how big it is,
Yeah.
I guess. I don't know.
Not too bad.
I think it was a lot heavier with the end plates, but we can actually weigh the end plates real quick too. We're 32 pounds all in on the front splitter. Not the lightest thing, but also not bad when you consider that it's the size of half of a car. All right, so this guy's 33 pounds roughly. So not bad, especially when you consider like these uprights. I mean, that's a lot of weight right here. A lot of the weight is right here. I think I've weighed a dual element before and it was about 15 pounds. So the actual wing elements are 15 pounds, and then we have 15 pounds of aluminum on the bottom side. So not bad. We're adding 60 pounds to the car to increase downforce to something around 3,000 pounds at, is it 160 or 180? I don't know, Matt. Matt can decide. He's the numbers guy. So Ryan's actually coming by, I believe, this week. So it's PRI week. So it's literally taken a full year. And he's gonna pick it up, put it on his car, and then he's gonna start hopefully tweaking it to figure out how to get the downforce and the suspension and chassis to work together, because that's gonna be a tricky situation. This is a lot of downforce, a lot of downforce. So it's gonna take some iteration, and then hopefully he'll start setting some fast lap times with the kit.